Okay, today we're going to talk about translations in the coordinate plane. A translation is like a shift, okay? So what we're talking about here is taking our shapes and we are shifting them, okay? Um, to translate, so when you see that word translate, you need to think shift. Translate the quadrilateral TYMQ 3 units to the right. Now, some vocabulary here. In this graph, TYMQ outlined in black is the pre-image. So the pre-image here in this figure is in black. Now, the quadrilateral T prime, Y prime, M prime, Q prime, notice that this little symbol here is called prime, okay? So that would be Q prime is how you would read that. That is the image, okay? So it's just like when you are seeing your image in a mirror, it's not actually you, it's a reflection of you, which we will do reflections also, but it is the new figure, okay? So the pre-image is always the original, okay? And the image is always the new position, okay? All right, so shifting. If we follow this mapping, that's another new vocabulary word. A mapping just tells you the rule of where it goes. So the mapping for this would be x, y, every point goes x plus 3, comma, y. If we want to shift our graph, or if we want to shift our shape to the right 3 units, all we have to do is add 3 in the x direction. So if we take y and we move that 1, 2, 3 units to the right, we have added 3 in the x direction. So that's all that's happening here. If you take points and even add, we would go 1, 2, 3, that moves 3 units to the right. D has moved 3 units, Q has moved 3 units. Notice the y value did not change because we did not shift up or down. Okay, so basically you add 3 to each x value or just shift each point 3 units to the right. If you shift your corners and then reconnect it, your shape should look exactly like your original shape. Remember, that was called congruent. So we could say that quadrilateral TYMQ is congruent to quadrilateral T prime, Y prime, M prime, Q prime. Okay, so a little review there of our symbols. Let's do another. Okay, so in this case, triangle WEG, we want to translate it, so that means shift 1 unit to the right and 2 units down. So that means that we want to go 1 unit that way and we want to go 2 units down. Okay, if we look at our picture, that makes sense. If I look at E, I went 1 unit to the right and 2 units down, and I know that E is the original and E prime is the new point, new position. Okay, so the mapping would say take every xy value and add 1 in the x direction, subtract 2 in the y direction. So pretty basic there, okay? That's what that looks like there. Now, again, if you shift each corner and then you reconnect it, automatically your shape is going to be congruent. A translation or a shift is a rigid movement. It does not change the shape or the size. It only changes the position. Okay, let's look at this one. Given the coordinates for triangle Jan, translate the triangle. So I'm translating it. Remember, that's a shift. Okay, 4 units left and 4 units up. Okay, we don't have a picture this time. We're just working with the points. So basically, you will subtract 4 from every x and add 4 to every y. Right? So you could even go through here and just say, okay, I'm going to subtract 4 for every x value. So that would be -5, -5, -1, and then we're going to add 4 to every y value. Did I say y last time? X, okay, add 4. So those would be our new points. So we could do that without a grid. All right, one more. Here we go. Use the graph at the right to write a translation rule. So this time, they're telling you how it moves. You're looking at the graph, and you're supposed to write the mapping. What would the rule look like? Well, what we need to do is pick a point like D and figure out how it is shifting to get to its image, the new position. Okay, so if we look at D, we would go 1, 2, 3, that lines up. So this appears to go to the right 3, 1, 2, 3, and down 3. Okay, check that with all the other ones. Looks good for D, but let's just make sure. 1, 2, 3, 1, 2, 3. Yep, if we look at K, they seem to be moving in the same direction. So that means that every XY point, so XY, our original X and Y, would change or map into X plus 3 and Y minus 3. Okay. That's what we want. Okay. So that is basically what translations look like. Remember, they are shifts, and that's what you will practice.